Okay, so what I want to do with this PowerPoint is just quickly go through those first few pages that you were to take notes on, pages 1 through 10, and just highlight what I think some of the major topics are in this chapter. So you might want to have your notes out. You could star, underline, or highlight things that I mentioned. You might want to pause and make a note that you need to add a definition. But these are the things that I think are important. So your book starts off and it talks about some definitions. So make sure you can define what the environment is. So remember, the environment is all living and non-living things around us. And the important thing here is that it includes us, right? So it includes how we affect the environment and how the environment affects us in turn. And so when we study environmental science, that's actually what we're studying. We're studying how the natural world works, how our environment affects us, and how we affect our environment. Okay? Towards the end of those 10 pages, you're also going to see a definition for environmentalist. So make sure you understand the difference between an environmental scientist and an environmentalist. So there's some similarities and there's some differences. Okay, your book also starts talking a little bit about natural resources. And this is something that we're going to come back to over and over again as we go through the year and talk about different resources and how they're used in different ways. So really, if you look over on the left-hand side with these renewable natural resources, these are things that we're not going to run out of. Sunlight, wind energy, okay? So these are pretty much infinite. If we look over here on the right, we have non-renewable natural resources. These are things that we have a limited supply of. There might be a lot of it, but it's still a finite amount. And when we use it up, there's no more left. All right? But it's kind of on a continuum. You can think of resources kind of here in the middle that are renewable. So for instance, fresh water, right? The water cycle is renewable. So you can think of an aquifer. The water does get recharged, but here you really need to think about how fast it's being renewed versus how fast we're using it. So in the case of water, if we're taking more out of the aquifer than is naturally being replaced, then it really becomes a little bit more of a non-renewable resource. So we have to think about those two ideas. Okay. Another thing I want you to start thinking about, because it's going to, again, come up again and again throughout the course, but also because it tends to be something that occurs on AP exams, is the definition of ecosystem services. All right, and you really want to think of an ecosystem service as something the environment does for us, and then we don't have to do it. So for instance, purifying water. All right, we normally have to put a lot of money into building wastewater treatment plants to treat water, to try to stop pollution. But certain areas of the ecosystem actually can do this for us. So that's an ecosystem service. And we have to think about what ecosystem service is available, all right? And then when we talk about environmental economics, we'll think about what the economic impact of these are. Okay, your book also brings up just a little bit about population in these first few pages. This is really just an introduction. We're going to talk more about population in a later unit, so we'll go into this in more detail. Right now, especially on this graph, what I want you to know is, what do we mean by agricultural revolution? So what happens here that then causes the population to sort of start to gradually increase? All right, so it's gradually increasing. And then here we see this really sudden exponential increase. Sometimes this is referred to as a J-shaped curve. And this really occurs due to the Industrial Revolution. So what's happening here that's leading to this sudden population increase? So make sure you have that in your notes, okay? All right, when we think about population, your book just brings up a couple people that you want to be familiar with and recognize their names. So this is Thomas Malthus. And previous to Thomas Malthus, people really just thought population growth was good, right? More people to work, more people to bring in food crops. It was considered an economic growth issue. But he was really the first person that started thinking about what happens when population growth starts to increase without a check on it, and it overcomes how much resources are available. Okay, so in 1798, he wrote an essay on the principle of population, and he really had kind of a dire outlook. So he thought if population growth was unchecked, that populations would then increase more than the resources that were available, and this would lead to war and conflicts and starvation and disease. Basically, that would act to then bring the population back down again. He was very influential, both in economics and in biology. So Charles Darwin was very influenced by his ideas, and we'll talk about that a little bit when we talk about evolution. All right, the next person that we want to be able to recognize as far as population goes is Paul Ehrlich. So he actually wrote this with his wife, Anne Ehrlich, even though she didn't get much credit for it. But in 1968, they wrote The Population Bomb. And again, this is the idea that the population explosion is going to unleash famine and conflict. It was, it was really kind of a very negative outlook on population growth at this time. And we'll talk about later on when we talk a little bit more about population, what aspects of the book are still pertinent and maybe some of the things that he got wrong. So basically, a lot of his predictions, at least so far, have not come to pass. And some of that is because there have been agricultural and technological advances that have been able to counter some of the population growth. So we'll discuss this in more detail later on. Okay, one of the things that's important when thinking of population is that it's not just population numbers, right? So it's easy to see how the more of a given population, the more effect there are on resources, but it's also how much resources individuals are using. All right, so this map is looking at that human ecological footprint. Okay, so that's another big idea that we're going to hear about throughout the course. So each chapter is going to come back to this idea of what the ecological footprint is. All right, so make sure you've got written down that nice definition that the ecological footprint is the cumulative area of biologically productive land and water required to provide the resources a person or population consumes and to dispose of or recycle the waste the person or population produces. Right? That's a mouthful, but it's basically talking about how much resources a population is using. So you can see from this map where the red, the hot spots are, and you can think about that as we go through the next few slides, what's happening in those areas that the human footprint is having the most impact in those areas. Okay, another way to look at this is thinking of the world population in its entirety. So what's happening to our population and how many resources there are? And according to this analysis by this research group, they're basically indicating that we have already overshot the Earth's biocapacity. So its capacity to support us by 64%. So it's basically saying right now we are using way too many renewable resources faster than they are being replenished. Okay. So again, remember in that first slide, even though water is replenishable, if we're taking out more than can be regenerated, we're in trouble. And so some of these analyses are showing that our footprint may be higher than the resources that are available. Okay, and then this is looking at it sort of instead of the whole world population, by countries. So which countries have the highest ecological footprint and why? So you want to go back and read that section in the book and really think about why Mexico may have a lower ecological footprint than the United States. What's happening? What are those populations doing that might be responsible for that? All right, and then here's just a little math to start practicing. So how many citizens of Mexico does it take to equal the average ecological footprint of the average citizen of the United States? All right, so that's pretty straightforward. All right, and then if the world average is about 2.2 hectares per person and the US is 9.6, how much more than the average world footprint is the United States? Okay, and you can think about why this might be the case. All right, and that leads into your assignment. So you want to go on the website that I provided, and you're going to calculate your own individual ecological footprint. So you can see, are you using more or less than the average person? And if you go through it a couple times and change some of your answers, you can kind of think about what things make the most impact. So is it what car you drive? Is it the food you eat? Is it where you live? So think about what things might be contributing to a higher footprint than either other people in the US or other people in the world, okay? And we'll come back to this issue when we start thinking about policy, because this slide right here really impacts how a lot of environmental policy is now being discussed and what a lot of the conflicts are between different nations, okay? All right, so those are the first 10 pages. We're also going to talk a little bit about the Easter Island example that's given in your book, so please read through that, but we'll come back and say a little bit more about that later in the week. All right, hope this has been helpful, and I'll see you in class.